So yeah, hi, welcome guys. This is the session 2 based on the chapter Quadrilateral. See, in our earlier session, we had covered up everything that was related to the concept of quadrilateral, and we had understood various type of quadrilaters like your rectangles, parallelogram, square, rhombus, trapezium, trapezoid, or you can say isosceles trapezoid. So we had understood each and everything, and there was one most important concept there that I had discussed. It was the difference between kite and a rhombus. So we had covered each and everything starting from the scratch, that what is a quadrilateral, what are the various properties of a quadrilateral, what are the terms related to quadrilateral. So we had covered up each and everything. And now today we are going to begin with the session 2 where we had left from in our earlier session. So remember, we had just completed our 2 theorems, and I told you that we will be following up with the theorems in our next sitting because I did not want you guys to be bored or you just everything passing through right above your head, because I wanted you guys to grab each and everything. So that's why I did not cover each and every theorem in the last session. So I will be covering it up today. We will be following up with the exercise 8.1, and hopefully I might be able to complete that exercise today. Or if we are not able to complete that one, we can always pick up with this next session. These kind of chapters, see the chapter like quadrilaters, area related to parallelograms and triangles, your triangles and its properties. These 3 chapters are quite important. They are not like the chapters that you have already learned with me, like your chapter 1 number system, and till your chapter 4 you can consider your chapter 5, but we haven't done that chapter yet because that chapter is pure theoretical. So we can cover that chapter in just one sitting anytime we want. Remember, the first 4 chapters are quite easy. You can just do them in one sitting also if you have the practice. But these kind of chapters are not that much easy. They have to be covered up in slow and steady pace so that you guys will be able to grab each and everything, because most of these sums will be related. They can be remolded and they can be asked in a variety of ways. So I want you guys to understand each and everything to its various to its foundation, so that you guys will be able to attempt any question that has been asked. So with that being said, let us just revise each and everything. And obviously, if you are unable to revise or you recall anything, you are having any doubts regarding your previous session, you can post your doubts right here. And for that, you have to do what? You have to just log on to our website, or you can just download our application. In order to have your doubts posted to me, you have to get yourself registered, and that is quite easy. We have already posted the steps to get yourself registered. You can either follow the steps from that video, or you guys are intelligent, you can just follow with that. So download our application, get yourself registered, ask as many doubts as you want. I will be happy to clear out your every doubt related to any chapter, from this curriculum, whether that chapter has already been discussed or that is yet to be discussed. I will try to clear it out separately if that is possible, or we will be having doubt sessions and I will be happy to have doubts from your end too. I don't want to just put everything out in front of you. I want to have the inputs from you. So guys, remember, you have to ask your doubts too, right? So for that, obviously get yourself registered, download our application. With that being said, let us start with the video, and let's study this chart real quick, in which I have just summarized each and everything that was in our yesterday's session. So remember, we had here vertically, we have what? See, these rows are your types of quadrilaters, and these are the columns that are the specific properties related to those quadrilaters. So you guys see, if I move like this, I will be having each property related to a particular. So before we get to this, let's just understand the type of quadrilater. So let's remember what actually the quadrilater was. So you guys see, your quadrilater was what? It was separation of two words, quad and lateral. Quad means 4, lateral means side. So any 4-sided figure was your quadrilater. And there were actually 2 categories of quadrilaters. One was your concave quadrilater and another was your convex, right? Now what are these two? If you are going to ask me, I have already explained in the earlier session. For that, you just have to go back to that session, or you can do what? You can just, I've already told you, get yourself registered and have your recorded sessions there. You can just observe this from there, right? So this is not going to be explained today because I have various things to cover up. So I'm going to move forward, and let's recall the major properties. And all these types are your convex quadrilater for that matter. So these are your types of convex quadrilaters. So with that, your very first convex quadrilater is a parallelogram. So basic figure of a parallelogram is like this. This is your parallelogram in which you have what? You have four sides. Let's say ABCD is a parallelogram, right? So name will be like this, parallelogram ABCD. So ABCD is a parallelogram in which you can see in parallelogram it is made up of two pairs of parallel lines. So you guys see AD will be parallel to BC and CD will be parallel to AB. So you guys see opposite sides are parallel, valid. Both pairs are parallel. Opposite sides are congruent. That means opposite sides are of equal length. You guys remember in case of parallelograms, opposite sides are equal and parallel. So that means if AD is parallel to BC, AD is also equal to BC because ABCD is a parallelogram. So opposite sides are congruent too. Opposite angles are congruent. That means opposite angles are equal. That has already been verified. Opposite angles are equal. That is true here as well. So angle A is equal to C, angle D is equal to angle B. We are going to cover this one up. We have some theorems based on this one. So we are going to explain this in a bit today. Don't worry. Diagonals are congruent. In that case, diagonals are not congruent. That means if you join AC and if you join BD, AC is not equal to BD, but they do bisect each other. That means this half will be equal. That means this will be equal to that one. This will be equal to that one. That means OA, if that central point is O, then OA is equal to OC and OB is equal to OD. Diagonals bisect each other, but they are not of equal length. They are not perpendicular. So diagonals bisect each other. They are not congruent. They are not perpendicular. That means they are not making an angle of 90 degree with one another. Four right angles cannot be possible because in such scenarios, in case of parallel lines, sum of adjacent angles is always what? It is always 180. But in case of parallelogram, specifically in the case of parallelogram, one angle will be acute, another will be obtuse, and together they will be 180. So that is the main thing regarding a parallelogram. I hope you guys are able to recall this one. And next one is your rectangle. Rectangle is what? It is a kind of a parallelogram in which each angle is 90. Opposite sides are parallel. Indeed they are. Opposite sides are congruent. Indeed they are, because rectangle is a kind of a parallelogram. So it will be sharing almost every property of a parallelogram. That will be the main thing to understand here. Now it will be having opposite sides parallel, opposite sides congruent, opposite angles equal. See, it is 90 and that is 90. They can be equal. Adjacent angles can be equal to in this case. And diagonals bisect each other. If I join these two, if I join the opposite vertices, let's say this is ABCD. ABCD is a rectangle. So if I join AC and BD, then you guys can see they will be bisecting each other. They will be of equal length as well. That means AC will be equal to BC. AC will be equal to BD. That is a special property for the case of rectangle. It is not available in your parallelogram. See, diagonals bisect each other. Diagonals are not congruent. So you guys see that is possible here. And you guys see diagonals are not perpendicular yet. They are not perpendicular. They are of equal length. They do bisect each other. That means if I have this common point O, then OA is equal to OC, OB is equal to OD. And since diagonals are equal themselves, so you can say OA is equal to OC is equal to OB is equal to OD. So they are of equal lengths. So that is the main thing. Four right angles are there. Then we have the case of rhombus. Rhombus is what? Rhombus is also a kind of parallelogram. It will be sharing almost each property of a parallelogram, but there will be some special cases. Firstly, rhombus is what? Rhombus is kind of like this. This is a kind of general shape of your rhombus. So it looks like this one. Let's say ABCD is a rhombus. Although people might get confused that this is a kite. Remember, kite is not a rhombus. Kite is different. A rhombus can be a kite, but kite cannot be a rhombus. That is the main thing to be noted here. So you guys see, in this case, opposite sides are parallel. Obviously they are. But in the case of rhombus, each side is equal to. That means opposite sides are parallel, opposite sides are congruent, adjacent sides are congruent too. So you can see each side is congruent to one another. So guys see, AB will be equal to BC equals to CD equals to DA. That has already been discussed. In this case, you guys see diagonals bisect each other at 90 degree. That is the main thing. So if I join AC and BD and this point is O, you can say AO will be equal to OC, and each angle right here at the center, at the intersection of your diagonals or the bisection of the diagonals, that will be 90 degrees. So remember, angle DOA equals to angle BOA equals to angle COA equals to angle COD. Each will be 90 degree. AO will be equal to OC and DO will be equal to OB. That is the main thing to be noted here. And each side is equal. So that is the property, or these are the properties of your rhombus. Then we move forward and come to the point of square. So what is a square? Remember, a square is also a parallelogram. Square is also a parallelogram. Bear with me. Square is also a parallelogram. It shares some properties of parallelogram, some properties of rectangle, and some properties of rhombus too. So you can say if it is sharing all these three properties, then it will be having each and every property of these above three type of quadrilaters. Now bear with me. I know what a square is. Square is a kind of like this figure, right? This is a square. If I want to define the square, a square is what? A figure or a quadrilateral in which each side is equal. So each side is equal. Let's say ABCD is a square such that AB is equal to BC is equal to CD is equal to DA. In this case, remember, each side of square is equal. Each angle of square is also equal. That is 90 degrees. Angle A equal to angle B equals to angle C equals to angle D. It is 90 each. So you can say opposite angles are equal to. That is the property of parallelogram. In this case, opposite sides are parallel to. You guys see AB is equal to CD. It can happen AB is parallel to CD also, because sum of these two angles, it is 180, and you guys remember sum of co-interior angles is always 180 in the case of parallel lines. So this defines the property of parallelogram already included. Rectangle already included, because in the rectangle opposite sides are equal, and you can see AB is equal to CD and you can say BC is equal to AD. So rectangle's properties are here as well. You guys remember rhombus has all sides equal to. We have all sides equal here as well. Special property, rhombus has its diagonals bisecting at right angles. So in this case, but a special property, you guys remember, in this case, it will be sharing the properties of rectangle, parallelogram, and rhombus. So in this case, you guys must remember this. In this case, diagonals of a square are equal, AC is equal to BD, and diagonals of square bisect each other as well. So that means this point, if this is the common point O, OD is equal to OB, OA is equal to OC, and each and everything is equal to themselves. That means OA equals to OB equals to OC equals to OD. So you guys see, each and every tick will be present here. So that will be the main thing to be noted. If somebody asks you, is square a parallelogram? It can be a parallelogram. But can a parallelogram be a square? No, it cannot be, because parallelogram has only 4 properties. Square has important properties to be noted here, which are diagonals are equal, diagonals bisect each other at 90 degree, and most important thing, each side is equal, while in the case of parallelogram only opposite sides are equal and parallel. Can a square be a rectangle? Indeed, a square can be a rectangle, because opposite sides are equal and square has each side equal, so you can say opposite sides are equal as well. But can a rectangle be a square? No, rectangle cannot be a square, because rectangle only has opposite sides equal, but square has all sides equal. One more difference, rectangles diagonals do not bisect each other at 90 degree. That is the main thing here. They are not bisecting each other at 90 degree. They are bisecting each other but not at 90 degree, while in the case of square, they are bisecting each other at 90 degree. They are equal to, and 4 right angles are already present. 4 sides are congruent. So that will be the main thing to be noted here. In case of rhombus, opposite angles are equal. Remember, opposite angles are equal. No angle is 90 degree. So see, 4 right angles, they are not present in this case. So only 4 right angles are present in the case of rectangle and square. So I hope you guys are able to understand the difference between the major 4 type of quadrilaters. And now come to the point of kite. Remember, in case of kite, your adjacent sides are equal, not opposite sides. If I just draw a kite, now you guys must be recalling, or you have seen the kite, right? So let me just draw a kite. Let's say this is the kite right here. So you guys see, in the case of kite, adjacent sides are equal. So no opposite sides are equal, only adjacent sides are equal. And in this case, you guys see, diagonals are just perpendicular. They form an angle of 90 degree at the center while they are intersecting, but they are not bisecting each other. They are not equal. None of the angle is equal, and that will be the main thing to be noted here. So these are the cases related to your, I hope you have cleared your doubt related to your kite and rhombus. Now coming to the point of trapezoid and trapezium, or isosceles trapezoid. See, trapezoid is what, or you can say trapezium. Trapezium is what? It is this kind of a figure in which you have a pair of parallel sides and a pair of non-parallel sides, such that parallel sides are not of equal length. They are just parallel, they are not equal. Remember, in case of trapezoid, opposite sides are parallel, opposite sides are not congruent. See, only opposite sides are parallel and everything else is not available. See, in case of this, diagonals are not equal, diagonals do not bisect each other, diagonals are not perpendicular bisector of one another. There is no such angle as 90 degrees in this case. So remember, in this case, only the pair of lines which are parallel, sum of those co-interior angles, that will be 180. Remember, that will be the main thing to be noted here. While in the case of isosceles trapezoid or isosceles trapezium, it is what? It is this, that the opposite sides will be congruent, or you can say opposite sides will be equal, provided those opposite sides are in non-parallel sides. So in case of your isosceles trapezoid or trapezium, the non-parallel sides are equal, opposite sides are not equal. That means the parallel sides can never be equal, only non-parallel sides will be equal. So I hope you guys are able to understand each and everything, because I've just spent around 10 to 15 minutes explaining this concept. I hope you guys are able to understand now and you are ready to go. So let's start with the video and let's cover up with our theorem 5 now. So I guess we have just covered up theorem 4 in our last session. So in a quadrilateral, each pair of opposite angles is equal, then it is a parallelogram. See, in a quadrilateral, each pair of opposite angles is equal, then it is a parallelogram. Remember, if I draw a quadrilateral, let's say this is a quadrilateral. Actually, we are not going to draw it like, but we have to prove it like parallelogram. So let's say this is a quadrilateral. We are going to draw it like this. So let's say this is a parallelogram ABCD, and you have been given that angle A is equal to angle C, angle D is equal to angle B. Given is what? Given is ABCD is a quadrilateral such that angle A is equal to angle C, sorry, not B. Angle A is equal to angle C, angle B is equal to angle D. That is the main thing. Now, required to prove is what? Required to prove is RTP. It is ABCD is a parallelogram. We have to prove this one. Now, for this, if I just come back to my native ink, so proof. So you guys see, if angle A is equal to angle C, angle D is equal to angle B, if I do what? If I just try to apply the angle sum property of a quadrilateral, you guys must be remembering this, that angle sum property of quadrilateral suggests that each angle of a quadrilateral, if you add all four angles, the sum will be exactly 360 degrees. That is the main property of a quadrilateral. So if this is the case, angle A plus angle B plus angle C plus angle D, that should be 360 degrees, right? This angle sum property of quadrilateral, right? Now I know angle A is equal to angle C. So in place of angle C, can I write angle A? So angle A plus angle B plus angle C, and I know angle B is equal to angle D. So can I write angle B in place of angle D as well? So in place of angle C, I'm going to write angle A. In place of angle D, I'm going to write angle B equals to 60. Now you guys see, angle A, twice of angle A, angle B, twice of angle B, which is equal to 360. If this is the case, then I can say angle A plus angle B equals to 180. You guys see, sum of two adjacent angles, or you can say co-interior angles, it is 180. Then the lines are parallel. You can say AD is parallel to BC. Similarly, if you had taken angle A instead of C, then it should be angle C plus angle C. So angle C, and you can take angle B. You can do anything that you want. You can do it accordingly. See, you can do this. In place of angle A, you can write angle C. So you can say twice of angle C plus twice of angle B equals to 360. Then angle C plus angle B, that will be what? That will be 180. You guys see, sum of these two will be 180. Then AB will be parallel to BC, so CD. And you guys see, a pair of opposite sides opposite sides are parallel twice. That means both pairs of opposite sides are parallel. Then you can say, therefore ABCD is a parallelogram. That is the main and the simplest proof then that you can use in order to prove it. I hope you guys have understood the case. See, if the sum of co-interior angles is always 180, then you guys remember, you have learned this in your lines and angles. If the sum of co-interior angles is 180, then the lines are parallel. I knew angle A and angle B together were 180. That was not specific whether they were 90 each. Don't get there. You guys know rectangle is a parallelogram, but a parallelogram is not a rectangle. We have been asked to prove it is a parallelogram. We haven't been asked to prove it is a rectangle. So it does not matter whether an angle is 90 degree or not, because rectangle can be called a parallelogram, but a parallelogram cannot be called a rectangle. So it is a freedom for you now. that if you somehow prove the sum of co-interior angles to be 180, then you can easily say if these two angles are 180, then this will be the transversal, AB will be the transversal, then AD will be parallel to BC. Similarly, if angle B and angle C together were 180, then you can say this BC will be the transversal, then you can say AB will be parallel to CD. And you guys see both pairs of opposite sides are parallel, and henceforth you have the figure which is a parallelogram, because parallelogram states that opposite sides are equal and parallel. We don't have to go for equality, we just have to go for the parallel theorem. See, if you had any doubt that why are we not proving it to be equal, remember, except your trapezoid and your kite. Kite is totally different. Except these two figures, each type of quadrilateral, whether it be your rectangle, whether it be your square, whether it be your rhombus, each of those has opposite sides equal and parallel. The main thing is they have parallel case. They are actually parallel. Opposite sides are parallel. So we just have to go for parallel case. We are going to prove that the opposite sides are parallel. Once we have proved that thing, we can easily say that the given figure is parallelogram. That is what we have done here now. So that's why I did not go for equality. I just went for this. I hope you have understood the case. Now let's move forward and see our theorem 6. It states that diagonals of a parallelogram bisect each other. Now we have been given that we have a parallelogram ABCD. Let's form its diagonals, join AC and let's join BD. So in this case, we have to prove that diagonals of parallelogram bisect each other. Now this is the case. If they intersect at O, we have to prove that OD is equal to OB and OA is equal to OC. We have to prove this one. Now this is quite easy. You guys must remember this. If the lines are parallel, if we have been given that ABCD is a parallelogram, then I can easily say AD is parallel to BC, AB is parallel to CD. Now you guys see, if AD is parallel to BC and BD is a transversal. Now you guys see this angle right here and that angle right here. Alternate interior angles, they will be equal, right? See, if I draw the parallel lines, they are like this, and that is a transversal. If I just go on like this, angle with the transversal and the parallel line, angle with the transversal and the parallel line, both are opening their faces in the opposite direction. They will be equal. How? They are alternate interior angles. I hope you guys are able to recall this one. See, I had told you at the beginning of a chapter 6 that you are going to use each and every property from there in your upcoming chapters. So here it is. We are going to use alternate interior angles, the pair of the angles which are separated by the transversal on the either side. So you guys see, these two will be equal. Similarly, this angle right here will be equal to that one. Angle. Now we cannot have another angle. You guys cannot say that these two can be taken as vertically opposite, and you can easily say these two triangles are congruent, and you can say this side is equal to that one, this side is equal to that one, CPCT. That cannot happen here because there is no such congruency criteria, which is angle. We can have angle side, we can have angle side angle, but we cannot have side angle. We cannot have angle. So these two are non-existent. So in this case, and also remember this, you cannot say OA is equal to OC and OD is equal to OB, because we have to prove that one. So in this case, I also know that the figure is parallelogram. So can I say AD is equal to BC, because in parallelogram opposite sides are equal and parallel. So AD is equal to BC, angle DAO equals to angle BCO, angle ADO equals to angle CBO, and you can say angle side angle triangles are congruent, and CPCT, OD is equal to OB, OA is equal to OC, or you can say AC bisects BD. That is the main thing. Now for this, let's write given. Given is ABCD is a parallelogram, right? Then AB is equal to CD, AB is parallel to CD. BC is equal to AD, BC is parallel to AD. Also, if BC is parallel to AD and BD is transversal, therefore, can I say this? Angle ADB equals to angle CBD, ADB this one, CBD this one, and angle DAC equals to angle CBD. These two are, sorry, we have written the same thing right here. Just give me a second. This will be BCD. Sorry, yeah, BCD, BCA. Let me just erase this. I think I've just confused you. See, this was the case. DAC BCA, angle BCA. Both are what? Alternate interior angles, right? These are the main thing to be noted here. Also, I have already everything here. So required to prove is OA is equal to OC and OD is equal to OB, or you can say AC and BD bisect each other. That is the main thing to be noted here. So now solution is quite easy. You can say proof is quite easy. So I'm going to take any two triangles. You can take any two. I'm going to take these two. You can take these two as well. Choice is yours. So in triangle AOD and triangle BOC. Reason being, only these two triangles or these two triangles, they can have the bisected, or you can say the divided diagonals. None of the others will be having that. So you guys see in these two triangles, I can say angle DAO, since we are not going towards C, equals to angle BCO, angle ADO equals to angle CBO, and you can easily say AD is equal to BC. So angle side angle using ASA, triangle ADO is congruent to triangle BCO, and you can easily say OD is equal to OB, OC is equal to OA, CT. So I hope you guys have understood the case and you don't have any doubt in this. So that will be the proof right here, and this is the proof that we had to have. Theorem 8.6 states that diagonals of parallelogram bisect each other. So that will be the main thing to be noted here. I hope you don't have any doubt in this. Now let's move forward and see what do we have. So this is the theorem 8.7. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Now you have to just have the bottom up approach right here. See, the diagonals of parallelogram bisect each other. We had to prove this one. In this case, diagonals that do bisecting each other, we have to just prove that the figure is a parallelogram. So you guys see, if I just draw this one, I have been given that diagonals are bisecting each other. So that means if I draw this ABCD, this is O. So I have been given what? Given is OA is equal to OC, OD, OB is equal to OD. Right? We have to prove that ABCD is a parallelogram. So required to prove is ABCD is a parallelogram. So this is quite easy. You guys see, take these two triangles. Now in this case, you guys see this is equal to that one. This is equal to that one. Vertically opposite, these two are equal. So side angle side, triangles are congruent. You can easily say AD. So see, in theorem 8.8, we have to do what? We have to now prove that the quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. See, remember, just one pair of opposite sides is equal and parallel, then it can be a parallelogram. We have to prove that one. So this is quite easy. You don't have to just worry about it. Just draw the figure. Let's say this is a parallelogram right here. This is actually a quadrilateral, not a parallelogram. We are going to prove it. It is a parallelogram. So for now, let's just assume this is a quadrilateral ABCD. And you have been given that one pair of opposite sides is equal and parallel. Let's say AB is parallel to CD and AB is equal to CD. Now for this matter, if these are parallel, let's just join this. Let's join BD. Now I know this side is parallel to that one. Can I easily say this angle will be equal to this one? Can I say this or can I not say this? Obviously I can say this. See. Also, can I say this one? Now see. This side is equal to that one, this angle is equal to that one, and this side is common. Side angle side, triangles are congruent, both of these two, and you can easily say that angle ADB, which is this one, is equal to angle CBD, which is this one. You guys see the another pair of alternate interior angle is equal, then you can easily say this side is parallel to that one. So hence proved. Or you can do what? You can do this, that BC is equal to AD. If one pair of opposite sides is equal, that means another pair of opposite sides is equal, then the figure is parallelogram. So you can go either way. Remember this, what I'm going to tell you now. See, we had this figure and I had taken the help of another pair of alternate interior angles to prove that the given figure was a parallelogram, right? Let me just complete the figure that I was talking about. See, I know this and this. These two lines are already parallel, so their alternate interior angles will be equal. Now remember where to consider that alternate interior angle. I've already told you. Those angles which are formed with your parallel, one of the parallel line and the transversal. They will be on the opposite sides of the transversal, opening their faces in opposite directions. So you guys see, these two lines are parallel, so this angle and that angle, they will be equal as per the alternate interior angle. But remember, if you are going to consider this angle right here beforehand, that they are alternate interior as well and they are equal, then remember these two lines are not parallel. This line and this line, they are not parallel. They haven't been given to you that they are parallel. So you cannot just simply assume that these two angles will be equal. They might not be equal. For example, if you do what? If you just talk about your trapezium, right? Now in this case, I know these two lines are parallel, then I can do what? I can assume this angle will be equal to that one, but I cannot say this angle will be equal to this one. On looking, you guys see this is not equal. So remember, unless you have been given that the lines are parallel, you cannot assume that the two angles that you can see are in the opposite direction and separated by the transversal, they will be equal just because they are alternate interior. They cannot be, because the lines are not parallel yet. So I hope you guys have understood the proof here. So I'm going to do what? Let's just quickly draw a parallelogram using our highlighter. This will be looking quite amazing, I guess, right? It is quite easy. So we are going to do what next time? Let me just have this in my mind. We are going to do what? We are going to draw a figure like this. This looks quite pretty, right? So ABCD, ABCD a quadrilateral. AB is parallel to CD. AB is equal to CD. This angle is equal to that one. So in triangle ABD and triangle CDB, right? I know AB is equal to CD. I know angle ABD equal to angle CDB, alternate interior, and I know BD is equal to DB, common, right? So you guys see this is given. So side, angle, side, triangles are congruent. Triangle ABD is congruent to triangle CDB, and you can easily say angle ADB will be equal to angle CBD, CPCT. So another pair of alternate interior angle is equal, then you can say AD is parallel to BC, and you can easily say also BC. Sorry, let's not write BC first. Let's write AD first, and you can also say AD is equal to BC, CPCT. So you guys see another pair of lines, opposite lines, equal and parallel. Then ultimately the figure has to be a parallelogram, because in parallelogram both pair of opposite sides are equal and parallel. So I hope you guys have understood the case. So these were the 8 theorems that you have to remember in order to attempt your sums that are going to be coming up just in a bit. So I hope you guys have understood the case. Pause the video right here if you want to understand this once more. Try this proof on your own, then follow up with the sums that we are going to start now. So let's start with the sums now. Our very first sum. The angles of a quadrilateral are in ratio 3:5:9:13. Find all the angles of quadrilateral. Now this is quite easy. You have been given a quadrilateral. Let's say this is a, okay. I remember. Don't worry. Let's use the highlighter. Let's say this is a quadrilateral. Okay, let's say this is the quadrilateral. A, B, C, and D. Now you have been given what? You have been given that its angles are in ratio. Let's say these are the 4 angles. The ratio is 3x, 5x, 9x, and 13x. Now don't ask me why I've written the x, because you guys already know. We are going to do what? We are going to assume let ratio equals to x. Then you can easily say sum of all angles is 360. So you can say 3x plus 9x plus 5x plus 13x equals to 360. Here you can calculate the value of x, then you can find out the remaining angles. So this is quite easy. I hope you guys will be able to do this one. So I'm going to leave it for you. So that can be your homework as well. Just complete this question and get the answer. There is one more way to this question. We can use sum of ratios also. So sum of ratios and product of ratios, you can use that method also. So guys, see, sum of ratios will be what? 5 and this will be 12, that will be 18, 12 plus 18, that is 30. You have to find this angle. 3 over 30, total angle is 360. Calculate that one. This will be what? See, that cancels out. It is 36 degree. Similarly, 5 over 30 into 360. Or you can do what? Just cancel this one out. This will be 12. That will be 60. So you can easily calculate each and every angle using either this method or sum of ratios. Choice is yours. You can use any one of the methods that you want. So let's move forward and see with the next sum. This is the second question. Now this is from where your exercise gets exciting. So remember, this is an important question. It states that if a diagonal of a parallelogram are equal, then show that it is a rectangle. See, diagonals of a parallelogram are equal, show that it is a rectangle. Now remember, we have to draw the figure, the one we have to prove. So we have to prove the given figure into rectangle. So I'm going to do what? I'm going to draw a figure like a rectangle. So let's draw it like this. But choice is yours. You can draw it anyway. You can draw it a parallelogram also. So let's say this is the figure right here. Let's say ABCD is a parallelogram. For a moment, ABCD is a parallelogram. Its diagonals are equal. So AC equals to BD. Now this sum is quite easy. This is very easy. You just have to understand the properties of parallelogram. You just have to understand the properties of rectangle and how a rectangle can be a parallelogram, but a parallelogram cannot be a rectangle. You have to understand the difference as well. For this, remember just a fine difference in both cases. Rectangle has all of its diagonals equal. You have been given the diagonals are equal. One more difference, that in rectangle, each angle is 90. So your ultimate goal here is what? You have to prove that angle A will be 90, angle B will be 90, angle C will be 90, and angle D will be 90. Just in case, you have to do what? You have to just prove either of these four angles to be 90. I'm going to do what? I'm going to prove that angle A is 90. Then using the co-interior angle sum, I can say this will be 90. Since the lines are parallel in rectangle too. You guys see, in the rectangle, lines are also parallel, opposite lines, and they are equal to. So remember, AB will be parallel to CD and AB will be equal to CD. Similarly, AD will be parallel to BC and AD will be equal to BC. So remember, I just have to find out one of the angle and give it and prove it that it is equal to its co-interior one. Then we can easily prove that they are 90 each. So what I'm going to do, firstly I'm going to write given. So I know ABCD is a parallelogram. I know ABCD is a parallelogram, right? So if it is a parallelogram, remember it is a parallelogram, then we have to do what? We know AB will be parallel to CD and AB will be equal to CD. Bear with me, that is the main thing. Also, I know BC will be parallel to AD and BC will be equal to AD. One more thing, I know angle DAB will be equal to angle BCD, or you can say, let's write it normally. So I'm going to talk about the whole figure right now, so it does not matter whether we are going to fully name it fully or just the vertices. I know opposite angles are equal to, angle A will be equal to angle C and angle B will be equal to angle D. That will come handy while we are proving it. So you guys see, these are the things that I have to remember. And one more thing, that AC is equal to BD. That has been given to me, that the diagonals are equal. Now we have to do what? We have to prove it. Required to prove is ABCD is a rectangle. That is the main thing. We have to prove that ABCD is a rectangle. Now proof. So for this, we are not going to take these small angles. We are going to take this complete angles. In triangle, not angle, actually triangle. In triangle DAB and triangle CBA. DAB, that means this triangle, and CBA, that means this. So these two triangles, I know AD is equal to BC. This side is equal to that. I know BD is equal to AC. Diagonals are equal to, what else? I have two sides. Either I can have the angle in between them and I cannot see any angle between them unless half of angle D should be equal to half of angle C. This is no condition. I know only opposite angles are equal. So there is no angle here. So remember, there cannot be side-side angle case. So we can do what? I can see this AB common in both. So AB is equal to AB. So you guys see side, 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 triangle DAB is congruent to triangle CBA, right? Both are congruent. I can say which using which property? Using Sss property, and now I can easily say angle DAB equals to angle CBA. Now we have to prove this one. So for this angle DAB, sorry, let's just do what? Let's erase the top portion here since we are almost done with the solution and we don't need a given portion. Let me just erase this and do the rest part at the top. You guys see, let's change the ink so that you guys can distinguish. I know, let's firstly write why we are going to do it like this. I know AD is parallel to BC and AB is transverse. So can I say angle ADB plus angle CBA equals to 180? This will be sum of co-interior angles, right? These two are equal themselves, so I can say twice of angle ADB equals to 180, and I can easily say angle ADB equals to 90. Or you can do one more thing. See, I know these two are equal, that is equal to that one, and this is equal to that one. So you can see all four angles are equal themselves. So you can say 360 divided by 4, because four angles are equal, each angle will be 90. So you can say this figure is, since angle DAB is 90, therefore you can say, sorry, we have taken the wrong name right here. This is DAB. ADB will be the opposite one, right? They are equal, they are obviously equal, and there some cannot be 180. This will be angle DAB, this will be DAB, and this will be DAB as well. So you guys see angle DAB is 90, you can easily say angle CBA will be 90. Since angle A is equal to angle C, then you can say angle BCD will be 90, and angle B is equal to angle D, then you can say angle ADC, that will be 90. Each angle is 90, therefore you can say ABCD is a angle. So I hope you guys have understood the case and you don't have any doubt in this. This is a very important question. Remember, this is very important. So I hope you are able to solve this one. If I give the sum to you now, you will be able to solve this one. I hope you guys have understood. So let's move forward and see with the third sum. So this is another important question. It states that show that if the diagonals of a quadrilateral bisect each other at right angles. Remember what it states. Let me just use the highlighter here. It says that show that the diagonals of a quadrilateral bisect each other at right angles. See, the diagonals are bisecting at right angles. They are bisecting. That means they are dividing one another into equal parts, and the angle between those parts is always a 90-degree angle. Then that is a rhombus. Now for this you just have to remember quadrilateral does not have a specific property, rather just four sides, four angles, and none of the angles is angles can be equal, none of the angles or none, all of the angles. See, if that is a total different case, remember in quadrilateral none of the side is of equal length. That is the main thing to be noted here. Sides can be of different lengths, but angle may or may not be. That is a total different case. But remember, we have to prove that it is a rhombus. So for rhombus, you have to keep in mind rhombus is what? Rhombus is that kind of quadrilateral in which each side is equal. None of the angle, that means only opposite angles are equal. None of the angle is 90 degree, but diagonals bisect each other at 90 degrees. That is the main difference between your general quadrilateral and a rhombus. That each side must be equal. So you guys see, if I draw a rhombus, because we have to prove it into a rhombus. So let's say this is a rhombus in our mind, although this is not the specific figure of a rhombus. Let's call this one, see, A, B, C, D. For now, ABCD is a quadrilateral in which diagonals bisect each other at 90. So you guys see, if I just join these two, diagonals bisect each other at 90. So these are 90, they are bisecting each other. This angle will be equal to, this side will be equal to this one, this side will be equal to this one. Now we have to prove that the given figure will be what? It will be a rhombus. Now how you're going to prove this one? See, if I take these two triangles, I can see this side is equal to that one. This angle is 90, this angle is 90. They both will be equal, and this side is common. Side, angle, side, both triangles are congruent, you can easily say AD is equal to AB. Then you have to do what? Then you have to go for these two now, or you can take these two. So either take these two or take these two. If I take these two, I know this side is equal to that one, this side is common, 90 and 90. Triangles are again congruent using side angle side. You can easily say AD is equal to CD. So guys, see, if AD is equal to CD, then ultimately you have to take these two as well. So you can say, see, you have to do it in 4 parts. Firstly, these two, then these two, then these two, or you can do what? You can do better, these two, and these two. Choice is yours, but you have to move with pair of triangles at a given time. Then you will be able to prove all the 4 sides equal, and you can ultimately state that that figure is a rhombus. So with this, I hope you guys have understood the case. Now let's start with the given. Let's write whatever we have been given. We have been given that ABCD is a quadrilateral. Right? It is a quadrilateral where AC and BD bisect each other at 90 degrees. Right? So this will be the case. So this means OA is equal to OC and OB is equal to OD and AC is perpendicular to BD. These are the two things. Now required to prove is ABCD is a rhombus. So we have to prove that ABCD is a rhombus. So for proof, let's start with the proof now. Let me just change the ink. So proof. So for this, we are going to do what? We are going to take 2 triangles at first. In triangle AOD and triangle AOB. I know AO is equal to AO is equal to AO, which is common. I know angle AOD equals to angle AOB, 90 each, and I know OD is equal to OB, that is given. You guys see side angle side, triangle AOD is congruent to triangle AOB, and you can easily say AD is equal to AB, CPCT. Right? Then you can do what? You can take these 2 triangles as well. Similarly, you can take these 2. Now, or you can do what? Take these 2. You can easily say similarly AD will be equal to CD. Similarly, CD will be equal to BC considering these 2, and ultimately you can say similarly BC will be equal to AB, or you can say AB equals to BC equals to CD equals to DA, and ultimately all 4 sides are equal, diagonals are bisecting each other at 90, then ABCD is a rhombus. So this will be the proof. I hope you guys have understood the case. See, if you want to prove it with each and every triangle to be taken here, so you can take what? You can take these pair of triangles now, then you will be proving this case. Then take these 2 pairs, you will these 2 triangles, you will be proving this case. Take these 2 triangles, you will be proving the last case, and ultimately you will be having each and every side is equal to one another, and you can ultimately state that the figure is a rhombus. So this will be the case. I'm going to do what? I'm going to wrap the video right here because I'm not going to bore you with any further sums. I hope these are sufficient for today. Practice these sums on your own. Practice each and every theorem on your own. Try to prove each and every theorem. Then come back to these questions and try to do them on your own. So these are the first 3 sums that we have covered up today. I will be back with tomorrow's session in which we are going to cover up the remaining portions, hopefully, because those sums are lengthy as well. That is not possible to predict, but I will be trying to cover up each and every question in a coming session. That means tomorrow's one. Till then, practice as much as you can. And remember, if you want to practice a bit further from your earlier chapters also, you are having trouble in finding correct books, don't worry, you don't have to shuffle through each and every book. We have just curated content available on our website and specifically on our application also. You just have to get yourself registered because we have a lot of question bank available. We have various test series based on each and every chapter. We have a lot of things available at your fingertips. You just have to do one thing: download our application, use your fingers, download it up, get yourself registered and join us. You can ask your doubts as well. You can have your recorded session as well. We have a lot of things there. So I'll be seeing you tomorrow. With that being said, practice as much as you can. Till then, bye and take care.